All right, so let's start. So today we are going to solve some of the problem from chapter 7, and it's about linear momentum. Okay, so this is the first problem. So let's try with, let's start with this one. So let's read this problem and see what it asks us to calculate. Okay, so if you read, you see that we are asked to calculate the average force. Okay, so if you read and then try to find what it asks us to calculate, it asks us to calculate the average force exerted on the tennis ball. Okay, what else we are given? So we are asked to calculate average force or just force. Okay, that we are going to calculate. What we are given? We are given the mass of a tennis ball. Okay, so mass of a tennis ball, and that is 0.057 kilogram. Okay, and and a velocity and a time is given. So here you see there's a velocity and there is a time. Okay, so now we have to understand what velocity we are given, what time we are given. Okay, so if we read correctly, you see that it says that, let me read just from here. Assuming that the ball's speed just after impact is 58 meter per second. Okay, so after impact, so here you see it says that after impact the velocity is 58 meter per second. Okay, so 58 meter per second is high compared to a low before impact velocity. So here we are not given the velocity of the before impact. That means we are not given the initial velocity. Okay, so because we are not given the initial velocity, we can approximate the initial velocity is equal to 0 meter per second. Okay, so the final velocity here it's given is 58 meter per second. Okay, now okay, so it also said that the initial horizontal component of the velocity before impact is negligible, so we can use that is equal to 0. And it said that to go from 0 meter per second to 58 meter per second, it takes like a 5 millisecond. Okay, so the delta t, the time delta t is given, that is equal to 5 millisecond, and you know that 5 millisecond means 10 to the power minus 3 second. Okay, so with this information, how to calculate the average force? So if you remember, one of the equation was something like this: delta p delta t, right? The force is equal to the rate of change of the momentum. Okay, the change in momentum is the final momentum minus initial momentum, right? And delta t is delta t. So initial momentum is equal to 0, right? Because the vi is equal to 0, initial momentum is equal to 0. So we can write this equal to this, right? And then this basically vf delta t. So we can now plug the values. So delta t is 5 times 10 to the power minus 3 second. Mass of the ball, tennis ball, is 0.057 kilogram. And the final velocity is 58 meter per second. So if you plug these values correctly in your calculator, it should give you these force. Okay, so the answer for this problem is 661 Newton. All right, now let's move on. All right, the next problem is this one. Okay, all right, so the next problem is this one. Okay, so here we have two cart. We know the mass of so let me call it cart 1. Okay, and let me call it cart 2. Okay, so it says that the cart 1, whose mass is this one, and it is moving at this speed to the right. So that means initially it was going in this direction, and the mass of cart 2 is this one, and it is moving to the right also, but at 1.33 meter per second. Okay, after the collision, it says that after the collision, what is the velocity of the two joint carts? Okay, so that means after the collision, they stick together. So if you remember, when two objects stick together after the collision, we call it perfectly inelastic collision. Okay, so the collision is perfectly inelastic. So if I now write down the equation, it will be something like this. I mean, conservation of momentum, it will be something like this. Okay, so we have to calculate v prime. Okay, so v prime, if you solve it for v prime, it is basically this. Okay, now we know everything right here. So we know the mass of object, I mean the cart 1, we know its velocity, we know the mass of cart 2, and we know its velocity. So we just now plug all the values here in this equation and see whether we can get these numbers. Okay, so this is 675 kilogram. Okay, so the number is given in gram, so we have to convert it into kilogram. Okay, the same thing for this one. Okay, so this is 675 kg kilogram, and then 0.75 meter per second plus 0.500 kg, and then 1.33 meter per second. Okay, so this is the equation after all plugging all the numbers here. And then if you plug all these numbers in your calculator correctly, it should give you this number. Okay, if I am not incorrect, okay, so it should be something like this. My calculator gave me this. Okay, so the final velocity after the collision, the joint cart will be moving with this velocity, and this here we get a positive sign, and positive sign tells us that both cart will be moving in this direction after the collision. All right, let's move on. So the next problem is exactly same. Okay, all right, so here we have two cars. Now this is a train cars. Okay, so this is a little bit simpler than the last problem. It says that car A is moving to the right with velocity VA, but the car B is at rest. Okay, after collision, they stick together. Okay, and moving in this direction I mean, we basically do not know which direction, but I think we are going to get a positive value. That means after collision, they will be moving in this direction. Okay. So if so, what is the final velocity? So here we have two problems. So here it asks us to calculate the common speed immediately after the collision. Okay. So the lock together, that means it is again the perfectly inelastic collision. Okay, if the car locks together as a result of the collision, that means it is the perfectly inelastic collision. And then what is the common speed after the collision? So that's the one question. And then we have to calculate the loss of kinetic energy. Okay. All right. So similar to the last problem, you can write down the conservation of momentum as these. So this will be A mb vb equal to ma plus mb v prime. Okay, so because they stick together, so here after collision I just write down, combine them together. But this is 0, right? Because the object B and the car B is at rest. Okay, VV equal to 0 here, you see that. So the equation is very simple now. MA VA, and that is equal to MA plus MB V prime. So V prime, if you solve this equation for V prime, it gives you this. Now, MA is 10,000 kilogram, and then VB, I mean VA is 24 meter per second. MA is again 10,000 kilogram. MB has the same mass of MA, so it will be again 10,000 kilogram. So this gives me, if I plug all this number in my calculator correctly, it gives me basically 12 meter per second. So after the collision, both cars are moving at 12 meter per second, and this positive sign tells us that it is going in this direction, in the positive direction. Okay. All right. Now the next part, it says that what is the loss of kinetic energy? Okay. I mean, it didn't ask, directly, but it says that calculate how much of the initial kinetic energy is transformed to thermal or other form of energy. That means there is loss of kinetic energy. So if I know what is the kinetic energy here initially and what is the kinetic energy finally, then we can subtract one from other and get the loss of kinetic energy to other form. Okay. So what is the kinetic energy here? So there, the kinetic energy for this one will be 0, because you know that the kinetic energy is half mv square, right? So this is the equation for the kinetic energy. So the initial kinetic energy is equal to half ma va square plus 0, because this is 0, right? The velocity for the second, the car B is 0, so its kinetic energy is also 0. So then if I plug the values here, we can determine what is the kinetic energy, initial kinetic energy basically. I get 2880. So it's a big number, this much joule. So this is initial. Let me use I, subscript I. And the kinetic energy final is half. Now finally both cars are stick together. Okay, they are locked now. So I have to combine car A and car B, and final velocity for combined cars are these, right? So V prime square. So what I will have then, kilogram, and then 12 meter per second and then square. So if I do this calculation, it gives me 1440 this joule. So you see that this is bigger, right? This is lower. So how much is lost? How much is transformed to other form of energy? That is this joule minus this joule. Okay, so it is basically this much joule. So this much kinetic energy is transformed to other form of energy, basically thermal energy. Okay, so it makes sense, you know, that when it collides here, right, there is a generation of thermal energy, heat between these two cars. Okay, and this mass energy is lost by thermal energy, and also there is sound is energy. Okay, all right, so here energy is lost, so you see that the kinetic energy is not conserved. Okay, and it makes sense because this is a real life problem, real life collision, and as you learn in the theory class that most of the collision in real life collision are elastic collision, inelastic collision, and in inelastic collision kinetic energy should not be conserved, and that makes sense. All right, let's move on. All right, so let's try this one. Okay, so here a car is traveling, okay, at 27 meter per second, collide with a building. Okay, so there is a collision between the car and the building. Okay, so here is the building. Okay, so before the collision the velocity was 27 meter per second. Okay, and after the collision the car stops, so the velocity is equal to 0. Okay, the driver's weight is given 860 Newton. Okay, all right, so W is given here, basically Fg, the gravitational force, is given 860 Newton. Okay, all right. So it says that the airbag, and the next line it says the airbag and the seat belt slow his velocity such that he comes to stop in approximately 2.5 seconds. Okay, so the time it takes to stop, okay, or the impact time, here you can say that delta t is equal to 2.5 seconds. Okay, so if so, what average force does the driver experience during this collision? Okay, again it asks us to calculate the force that yeah, don't confuse with this one. This is just a gravitational force. What I mean is the impact force. Okay, due to the collision there will be impact on the driver. Okay, and that impact force I want to know. So impact, so impact force is basically related to impulse. Okay, so if you remember, impulse is something like this: F delta t equal to delta p, or impact force is equal to delta p over delta t. Okay, so this basically this is the equation we want to use, and I want to calculate what is the impact force in this collision. Okay, so let me rewrite. Okay, So F impact is equal to delta P delta T. So P final minus P initial delta T. Okay, final is 0, right? Why it is 0? Because the final velocity is equal to 0. Because it is equal to 0, I mean final velocity is equal to 0, final momentum is also equal to 0. So this equation is mvi delta t. So the impact force is equal to negative mass times the initial velocity divided by the time. Okay. So for A, the impact force will be minus. Now we don't know m, right? The mass of the driver. So we need to know what is the mass of the driver. So how to get the mass of the driver? The velocity is 27 meters per second and delta t is 2.5 second. What is the mass? So mass of this driver can be determined from the gravitational force or the weight of the driver, right? So because the gravitational force is equal to mg, okay, so m will be 860 Newton divided by the gravitational acceleration, and that is equal to 87.8 kilogram. So plug this value 87.8 kilogram and see that you get negative 948 Newton. Okay, so negative 948 Newton is the impact force. Okay, so it's not that bad in that sense. Here this seat belt and the airbag helps the driver, okay, not to get a huge impact. Okay, now in the next problem, next number B, it says that without the seat belt and the airbag, his collision time would have been approximately 0.20 second. Okay, so here in the first problem, because of the seat belt and the airbag, the time was 2.5 second. Okay, so that's why the impact force is not that, I mean, large. But in the next problem, it says that if there were no seat belt and airbag, then the impact time will be very small, 0.20 second. Okay, so 0.20 second. So if the impact time is 0.20 second, then what will be the impact force? Okay, so you have to do the same thing for number B. Okay, number B, you have to change only this. Okay, so this is now 0.20 second. So if you replace 2.5 second to 0.20 second, it will be a huge number, 11,847 Newton. Okay, and this is a huge number. Okay, it is about 11 or 12 times from this number. Okay, so yeah, we have to be careful when we drive. Okay, in any case, always we have to, I mean, to avoid this kind of large impact, we have to always use seat belt, and we have to check that whether our car's airbag is working or not. Okay, it will help in any case of collision. I mean, in any case, if there is in collision, it will help us to avoid huge impact on us. All right, let's move on. So we have this as our next problem. Okay, So it asks us to calculate the recoil velocity of a 5 kilogram rifle that shoots a 0.020 kilogram bullet at speed of 620 meter per second. Okay. All right. So recoil velocity here means the backward push. Okay. So this is backward push. Okay. So so before the interaction between the, before triggering the bullet, triggering this, okay, both the bullet and the rifle were at rest. Okay, so before the collision, okay, before collision, collision means here the interaction between the bullet and the rifle. Okay, the total momentum is equal to 0 because both the bullet and the rifle were at rest. Okay, so after the collision, we have mass of the rifle, recoil velocity of the rifle, mass of the bullet, and the velocity of the bullet. Okay, so this equal to this. So before collision equal to the after collision. So from this equation we can write this. Okay, so we have to calculate the recoil velocity for the rifle. So if I solve it for a VR prime, it gives me something like this. Okay, and here the bullet's mass is 020 kilogram, rifle's mass is 5 kilogram, and the bullet's velocity is this. So if I plug all these values here in my calculator, it gives me something like this. So the velocity is in this direction. Okay, and it makes sense because as the bullet is going in this direction, okay, if the rifle is not going in this direction, then the momentum will not be conserved. Okay, so this tells us that that the velocity of the rifle is in the negative direction. Okay, and the magnitude of the rifle's velocity is 2.48, and because it is going in the negative direction, okay, it makes sense that it is a backward push. Okay, so the recoil velocity for this problem is minus 2.48 meter per second. Okay, all right. So this problem we already solved. Okay, so check the lecture. In the lecture we already solved this, so I'm not going to do it again here. Let's try this one. This is an interesting problem. Okay, so we have a ballistic pendulum. So ballistic pendulum is a device that is used to measure the speed of a projectile. So here projectile means the bullet. Okay, the projectile has mass m and is fired into a large block. Okay, so this is the bullet and this is the block. Okay, the block initially at rest and the bullet is moving at initially at v, at a speed v. Okay, and when it interacts, when the bullet interacts with the block, then both will be sticking together, right? And both will be moving at the same speed. So again, this is a perfectly inelastic collision here, right? So if I use the conservation of momentum, it will give us some information. Okay, so let's see. So before collision, we have m, v, and then m0. After collision, we have m plus m. Let's say the velocity after the collision is v prime. Okay, so this equation gives us a relation between the initial and final velocities. Okay, so I can write something like this. All right, but the question asks us to determine the relationship between the initial horizontal speed, that means this speed v, and the maximum height. And what is the maximum height? It says that as a result of the interaction between the bullet and the block, as a result of the collision, the pendulum and the projectile together swing up to a maximum height h. So you see that it is now here. So this h. So what we have to determine here is the relationship between this v and this h. Okay. Now, what we get so far is a relation between the initial speed and the final speed, or initial velocity or the final velocity. Now, to get a relationship between the h and v, we have to do something more. Okay, and here we can use our previous knowledge of conservation of mechanical energy. Okay, assuming there is no friction and no air resistance. Okay, so conservation of mechanical energy. Okay, so what is the conservation of mechanical energy? So we already learned in last chapter, conservation of mechanical energy is this, right? Now, what is the position 1 and what is the position 2? Okay, so we can think that just after the collision is our position 1. Okay, so this is the position 1 and this is the position 2. Okay, so just after the collision is our position 1 and just after the collision just after the collision is position 1 and this is the position 2, okay, at its maximum height. So just after the collision, okay, we should have kinetic energy, okay, because we know that there is velocity v prime. Okay, so because there is a velocity, there is kinetic energy. But because this is our reference line, okay, and think that this is our y equal to 0 point, y equal to 0 line. Okay, so from this line we we measure our height. Okay, so if this is our reference line, the kinetic the potential energy will be 0 because h equal to 0 at this point. Now at position 2, the kinetic energy will be 0. Why the kinetic energy will be 0? Because this is the maximum height. Okay, if the kinetic energy is not 0, it would move further, right? Because it is the maximum height, that means the velocity is equal to 0 and hence the kinetic energy is equal to 0. Okay, so at this point there is no velocity, v equal to 0, and v equal to 0 means kinetic energy is equal to 0 at the final position. But there will be potential energy, okay, because it is now at some height. Okay, now what is the kinetic energy? Kinetic energy will be this. Okay, we have to use both mass. Okay, both mass means mass of the bullet and mass of the block, because now the bullet is inside the block, so the total mass is the mass of the bullet plus the mass of the block, and the velocity here is this. So this is the kinetic energy. And what is the potential energy? Potential energy is again the total mass times the gravitational acceleration times the height. Okay, so now here you see that this and this cancel out. The equation becomes very simple. Okay, now we get a relationship between V prime and H. But the question asks us to calculate the relationship between V and H. So what we can do, we can substitute this here in this equation, and we will be getting something like this. V equal to M plus M divided by M, and then square root of 2 GH. Okay, so this is the relationship between V and the maximum height H. Okay, all right. All right, so this the next three problems are basically for the center of mass. So here we'll 8, 9, 10, 11. So next four problem basically where we are going to use the equation of the center of mass. Okay, so here we have 3-person, and 3-person can be thought as three different objects. Okay, so if we have three objects in a line, okay, something like this, what is the center of mass for this system? Okay, so let's think that 3-person as three objects in one line. Okay, so if this is a system, what is the center of mass? Okay, and it asks us to neglect uh, the board. So this lightweight board, so yeah, there should have some mass for this one, but it asks us to neglect this. If you neglect the mass of the board, what is the center of mass? Okay, so if you remember, the center of mass is very simple, right? Calculating center of mass is very easy, I think, right? XCM equal to M1 plus M2 plus M3, and then X1 M1 plus X2 M2 plus X3 M3, right? Now you see that X1, X2, X3 we are already given, and we know this. So this is X1, this is X2, and this is X3. So this is X1, this is X2, this is X3, and it tells us that the mass of person 1, 2, and 3 are the same. So M1, M2, M3 are basically M, okay, and X1 is 1 meter, okay, and mass of person 1 is M. This is 5 meter, and mass plus 6 meter and the mass. Okay, so here we have 3m, and then 1 meter plus 5 meter plus 6 meter, and m is common. So m and m cancel out. We have 12 meter divided by 3, so it is just 4 meter. So the center of mass for this problem is 4 meter. So in this problem, it is two-dimensional problem. Okay, so here we have to calculate both the x coordinate and the y coordinate of the center of mass. Okay, so how to do that? So it's basically very similar equation that we use in the last problem. So first let's calculate xcm, and xcm will be ma plus mb plus mc, and then xa ma plus xb mb plus xc mc. Okay, all the mass has this I mean all the masses are 2.5 kilogram. So again is very similar to the last problem. So it is 2.5 kilogram, 2.5 kilogram, and 2.5 kilogram. Okay, now xa is here at the center, at the origin, so that means x equal to 0. Okay, xb is this distance, that is 2 meters, right? And xc is again 2 meters because it is the x distance is just this one. Okay, horizontal distance. So from this line to this line is 2 meters. So it's again 2 meters. Okay, so once you have this, once you know how to write this equation, then the next is just plugging the number in your calculator, and my calculator give me this. Okay, similarly we can calculate ycm, and ycm is very similar to xcm. Okay, we have to just replace x by y. Okay, now again it is 2.5 kilogram plus 2.5 kilogram plus 2.5 kilogram, and then ya is 0. Okay, because this is at 0 and this is y equal to 0 line, so yb is also 0, but yc is this 1.50. So 1.50 meter, 2.50 kilogram. So once you understand this, then the rest of the thing is to plug in these numbers in your calculator correctly. So if you do it, what I did, it gives me this number. Okay, so the y coordinate is this one, sorry, x coordinate is this one, and y coordinate is this one. Okay, so these are the x and y coordinate of the center of mass. Okay, all right. All right, so let's do this one. So here again we have to calculate the center of mass. I mean the both coordinate x and y coordinate. So here we are going to use this as one particle, I mean one object. So this shape is one object and this as another object. So we have now MA and MB. Okay, so when we have something like this, okay, and if the materials are uniformly distributed, then we can think all the mass is concentrated at this point. Okay, so by knowing that xcm will be MA plus MB, and here it will be XA MA plus XB MB. Okay. Now let's say what is the XA? So XA will be this distance. Okay. So XA will be 2.06 divided by 2, because the whole thing is 2.06. So this is half of that. So it will be 1.03 meter. Okay, that's good. Now what is the XB? XB is this distance. Okay, so this is x equal to 0 line. So from here to here, this is the x equal to, XB. Okay, so XB equal to, you see, this is less than 2.06. The whole is 2.06 meter, and then this is 120 meter, and we have to subtract half of it, right? Because it's at the middle. So it is 0.10 meter. So XB is 1.96 meter. Okay. Now we know XA and XB. How about MA and MB? So we are not given any information about MA and MB. Okay. Then how to calculate MA and MB? So there is a trick. Okay. Now we are going to use our knowledge of density. Okay. So density is defined as density equal to mass per unit volume. Okay. So density is normally written as rho. Okay. Mass is m, v is volume. So mass can be written as rho times the volume. Okay. So mass equal to rho times volume. Now here volume is length, 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 width times thickness. Okay. So in symbol, I can write L, W for the width, and T for the thickness. Okay. All right. Now we know the length, right? So this is for A, this is the length. For B, this is the length. We know how wide they are. It's 0.20. Both are 0.20 meter wide. Okay. Thickness, although there is no information about thickness, but let's assume that the thickness is the same. And because it says that the uniformly distributed, the materials are uniformly distributed. Okay, so uniform. Okay, we can think that for both MA and MB, rho is the same. Okay, so if mass equal to this equation, okay, then what we see here is something like this. So XA, let me just write XA, okay, and then rho will be constant. Okay, I don't need to change rho. LA, it will be different because you see LA is 2.06, LB, the length of B is 1.48. So it will be different, but W is the same. So let me keep it. Thickness is the same. Okay. The same thing for XB, MB, rho is constant. So only different is LB, and then W and T are the same. Okay, so similarly in the denominator I can write this. Okay, now because all the term contain rho, W and T, we can cancel all these. So rho, 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 W, 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 thickness, 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 thickness. Okay, so once we do that, then it is very simple. XA, LA, XB, LB, and then LA plus LB. Okay, so what it is, XA is 1.03 meter, LA is 2.06 meter, XB is 1.96 meter, and LB means 1.48 meter. Okay, so 2.06 meter plus 1.48 meter. So if you then plug these numbers in your calculator, it should give you 1.42 meter. So the x coordinate is 1.42. Okay, now similarly you can do the y. Okay, so let me just erase some part, let me just replace x by y. Okay, so here we have to just replace x by y. Okay, so similarly you can show that the YCM is just this. Okay, now what is YA and what is YB? So that is the important thing. So we have to change this. Okay, so YA, let me erase now this and try to find what is YA and what is YB. Okay, so YA is this distance. Okay, so as this is 20.20 meter, so half of this will be 0.10 meter. Okay, and what is YB? YB is this distance. Okay, so this is the reference line. So this distance is the YB, and that is equal to half of 1.48 meter, and that is 0.74 meter. But because here you see this is the below y equal to 0 line, so we should have a negative sign. So YB here is negative 0.74. Okay, and this is 0.10 meter. So once you plug these values in your calculator, it should give you this. So if I'm not incorrect, so YCM would be negative of 0.25 meter. Okay, so that's it for this chapter. In next class we are going to start a new chapter, rotational motion.